Hey guys, this is Mrs. Dugan again, and today we're going to be talking about the types of graphs that we will use in the scientific method. Now, there's a ton of different graphs, but the three that we're going to focus on are a pie chart, bar graph, and a line graph. All three are really important because they all are able to represent different types of data. Our first one is a pie chart. We all remember what the pie chart is from elementary and intermediate school. So the pie chart is where we're going to show pieces of a whole. It's used to represent parts of a whole. Okay, so what that means is that think of when you're going to Thanksgiving, all right, and you want a slice of pie. Okay, but you've got 40 other relatives. You have to divide that pie according to, let's say, age. All right, so the youngest gets the smallest piece and the oldest gets the biggest piece. Okay, for example, another example is right here. These are the grades from the midterm. So as you can see, each part of our whole represents something else. For instance, the blue portion represents the number of A's I've had. The B's are represented by this orange. C's are gray. D's are yellow, and F's are this lighter blue. So when you have a pie chart, again, you want to make sure that it is used to represent parts of a whole. You have a whole group and you're showing how it's getting divided. They should always add up to 100% or that number that you have, the number of data points, and it really helps to show percentages also. Our next type of graph is our bar graph. This one is very common. So our bar graph is used to show comparisons between two things. If, for example, this graph is really showing the number of cookies they were eaten in the contest. You can easily see that Gary ate the most cookies and that Sasha ate the least, because you can look at Sasha and Dylan ate the least because you can look at how high that graph is. Just as we've talked about with variables and other things, our independent variable always goes on the x-axis because that's the thing that's changing. In this case, the contestants are changing. And the dependent variable always goes on the y-axis because that is what's being measured or observed. And our final one is our line graph. So line graphs are used to show changes over time. Now you may be like, well, Mrs. Dugan, the bar graph could do that too. Yes, but with your line graph, it's more of a fluid. It's more fluid. If we saw here, 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 it may not look as nice and you may not be able to see the trends. So with your bar graph, you're comparing, but your line graph, you are actually looking at the trend. Is it going positive? Is it negative? Is there no relationship? So if we look at this one, we have this series as population over time. These are in millions, let's say millions, okay? And this is the number of frogs. I don't know. I just made that up. But anyway, this is the number of frogs. So if we look at this gray, we see that it's plateaued and then it started to increase. So we would say that this is a positive trend because it's going up. Now, if you look at the blue, let's say the number of flies, maybe, all right, or the number of toads, you can see that there's a decline or a negative trend, and then there's a positive trend. Okay, and then we can see with the number of flies. Let's do flies this time. You can see that as the number of toads and as the number of frogs go down, the number of flies would increase. Okay, so again, your line graph is looking at trends. It's trying to show a change of something over time. Just as the bar graph, your independent variable will always go on the bottom because it's changing, and the dependent variable is what we're measuring. So it's going to go on the y-axis. Hopefully that clears some stuff up. Just remember, you can always come back to the video and refresh. Have a good day.